Today's lesson is in Unit 5, Introduction to Functions. We're going to be covering lessons 3 and 4, Interpreting and Using Function Notation. Turn to page 26 in your book. In today's lesson, the learning targets are: I can describe the connections between a statement and function notation and the graph of the function. I can use function notation to efficiently represent a relationship between two quantities in a situation. I can use statements and function notation to sketch a graph of a function. I can make sense of rules of functions when they are written in function notation and create tables and graphs to represent the functions. I can write equations that represent the rules of functions. Let's start on page 27 with the warm-up. All right, so here's a graph that represents the function f, which gives the height of a drone in meters. Okay, so we're looking at the height on the y-axis. That's going to be our output. Our input is time in seconds. Okay, after the drone leaves the ground, we're going to start at 0 and we're going to start timing it and see what happens. Now look at that graph and decide which function value is greater, if they are equal or if we can't tell. And then I want you to explain your reasoning. Think about what we did yesterday. Okay, we're using f for our function. What does f of 0 mean? What is the input? Okay, if you recall, the input is always going to be our x value. It's going to be time. Okay, so what does f of 0 mean? Or what does f of 4 mean? Can you tell if one of these is greater than the other just by looking at the graph? So pause now and go ahead and try 1, 2, 3, and 4, and then come back and let's compare answers. Welcome back. All right, f of 0, let's see what, if the x value, the input is 0, the output is going to be 0. The height's going to be 0 when we start. Okay, but after 4 seconds, the height is going to be 1, 2, 3, 4. It's going to be at 4 meters. Okay, so f of 4 is going to be greater than f of 0. Now what's greater, f of 2 or f of 5? All right, so let's look at our input. That's time. So f of 2, our output, our answer is going to be, again, 4 meters. But at f of 5, it looks like it's going to be the same. Those are two equal amounts because it looks like the drone is going up and then hovering at the same distance above the ground, 4 meters, between 2 and 5 seconds, and then it starts going down again. All right, let's look at f of 3. So f of 3, we're at 4 meters, and then f of 7 is 0. So 4 is greater than 0, so f of 3 is greater than f of 7. All right, now go to number 4. Is f of t or f of t plus 1 greater? So f of t could be anything between 0 and 7. So let's start with 0. F of 0 is 0. When x is 0 or when the time is 0, the output, the height, is also 0. Now let's add 0. Let's add 1 to that amount. So we're going to get 1. F of 1 is going to be higher. But that doesn't always work because look at 2 and 3. If we add 1 to 2 to get to 3, those are equal. And then if we have f of 5, which is 4, and we go to f of 6, that's going to be less than. So it's just going to depend on what t is. We can't tell. Okay, we can't tell which is greater. It depends on what the value of t is. All right, turn to page 27 if you're not there already, and work through these problems on your own, and then we're going to come back and compare answers. So let's read through it before you pause the video to start. We have a function p, and that gives the number of people in millions who own a smartphone. So let's highlight what we're looking at. P is our function, and we're talking about people in millions who own a smartphone. T is our variable, it's our input or our X. That's the year, or those are the years after the year 2000. All right, so what does each equation tell us about smartphone ownership? We have P of 17 equals 2,320. Can you put that into words? The same thing for P of negative 10 equals 0. Try this on your own. Do what you can, pause the video, then come back and we'll compare answers. Move on to question number 2 as well. All right, welcome back. All right, the number of people in millions is going to be our input. I'm sorry, not our input. Our input is going to be years after the year 2000. So let's see if we can interpret what this means. Okay, so our input is going to be the number of years after 2000. So add 17 to 2000. And we can say in 2017, about 2,320 million. Another way to say that is 2.32 billion people owned a smartphone. Okay, so we could write 2,320, multiply times a million. That would give us 6 more zeros on the end. 1, 2, 3, 4, 5, 6. And if we interpret that, this is going to be thousands, millions, billions. Okay, so that's how they got 2.32 billion. Okay. All right, let's go to this one. What is P of negative 20? Okay, T is our X or our input, but now we're inputting negative 10. So we've got to take away 10 years from 2010. Okay, and so that would bring us to 1990. In 1990, no one owned a smartphone. All right, now we're going to use function notation to represent each statement on question number 2, or part 2. In 2010, the number of people who owned a smartphone was 296,600,000. So what do we do with that? How do we write that with function notation? So remember, we're starting at 2000, so our input is going to be added to 2000. So this is going to be P of 10. We're adding 10 to the year 2000. Okay, is equal to 296.6, because this number we're going to have to multiply by a million. Okay, so you would have to divide this by a million, which, remember, a million has 6 zeros, so you're just moving that decimal place 1, 2, 3, 4, 5, 6, and it lands right here, 296.6 million. All right, in 2015, about 1.86 billion people owned a smartphone. So 1.86 billion. Okay, let's move that decimal not 6 places because we're talking about a billion. Okay, we've got to move it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in with zeros. And now let's convert that back to millions, because we've got to go by what the words tell us. And we've got to represent people in millions. So we'll start here at the end and move back 1, 2, 3, 4, 5, 6 places. So that's 1,860 million. All right, so this should be P of 15 because we're going to, again, add 15 to 2,000 equal 1,860 because we're talking about millions. All right, just go through this slowly, practice it, and pay attention to what the question is asking and how we're representing our answer. All right, the function P gives a number of people in millions, I'm just repeating what we've been doing, who own a smartphone T years after the year 2000. For part 3, question 3, part A, Mai is curious about the value of T and P of T equals 1,000. So just keep in mind, remember that T is time, okay? And our time in our word problem is going to be the number of years after 2000. Okay, what would the value of T tell Mai about the situation? Can you answer that before I uncover the answer for you? Think about it for a minute. T is going to tell us the year when, because we have that equal sign, when 1,000 people, or 1,000 times a million, so we've got to add 6 more zeros on. 1, 2, 3, 4, 5, 6. Put our commas in. Okay, we're taking those in groups of 3. So this is thousands, millions, billions. Okay, so this is the year when 1 billion people owned a smartphone. Adding the value of T to 2000 gives us the year. Is 4 a possible value of T here? So think about that for a minute. No, because T equals 4 corresponds to the year 2004. At that time, the number of smartphone owners should be below the year 2010, which was 296 million. Okay, so when we're going down, okay, it's going to be less than. Think about that for a minute. Write down these answers and then go back when you have time to review what we're saying. And if you don't understand, ask questions before we start the next lesson. You can ask by email. You can post your questions on the parking lot with a sticky note in the front of the room, or you can email me questions. All right, part number 4, use the information that you have so far to sketch a graph of the function. Okay, so let's think about what points we've already determined. Okay, we determined -10, 0, 10, 296.6, 15, 1,860, and 17, 2,320. So it's important that you are writing down what we talked about so you'll know where these numbers came from. Do you remember? -10, 0, 17, 2,320, 10, 296.6, and 15, 1,860. So we have those 4 points. Now we're going to sketch them. We're going to graph them. All right, we'll start with -10, 0. So that goes here. 10, 296.6. That goes here. 15, 1,860. That goes here. And 17, 2,320. So take a minute on page 28, sketch that in. Think about where we got those numbers. You can turn back in your book because I asked you to copy those down if you need to reference them. Make sure that you understand the x-axis is giving us time in years that we add to the year 2000. So we could go backward. This brings us to 1990. And then the population in millions, the number of people who own smartphones. Okay, once you have that graph, let's move on to activity 2. It's called boiling water. This is on page 29. All right, now we have a function W, and this gives us the temperature in degrees Fahrenheit of a pot of water on a stove T minutes after the stove is turned on. So what does W of 0 equals 72 represent? Remember, the input is always going to be time. So this means 0 minutes are at the starting point before we turn on the stove. Okay, the water is at 72 degrees before we turn the stove on. What does W of 5 greater than W of 2 mean? All right, the temperature of the water, 5 minutes. Input is always, this X value that we put in here is always going to be time. We're talking about minutes. Okay, so 5 minutes after the stove was turned on, that water temperature is greater than the temperature 2 minutes after the stove was turned on. What does W of 10 equal 212 represent? 10 minutes after the stove was turned on, the water temperature was 212 degrees. All right, can you do D, E, and F? Go ahead and try those. Pause the video and then come back and compare answers. For D, the water at 12 degrees was equal to the temperature of the water at, I said degrees, let me start over again. The water after 12 minutes of turning on the stove was the same temperature after 10 minutes of turning on the stove. KE, the water temperature after 15 minutes was greater than the water temperature after 30 minutes. F, the water temperature at 30 minutes minus the water temperature at, I can't tell what that is. It looks like a 2. Let me look in the book on page 29. Yes, that's a 2. The water temperature at 20 minutes. Now we're not subtracting 20 from 30. We're saying the water temperature at 30 minutes, whatever that was, and we subtract the water temperature at 20 minutes, we get 75 degrees. So the temperature, another way to say this is that the temperature decreased by 75 degrees between 20 and 30 minutes. So that's just a different way to say that. Okay, we're practicing function notation in context of the problem. So read through the lesson summary, look at these examples, and then focus on function notation. Try to understand what that means. Summarize this on your own, highlighting the important information, focusing on the vocabulary for function notation. Also, look at the graphs that are given, understand what the X and Y coordinates are giving us, and if you have any questions about what they're saying, bring those to class, place them on the parking lot, or email me, but try to it's your responsibility to understand the vocabulary. All right, there are a lot of examples here, so take your time and go through them so that we can start using the way that we talk about functions in class together. Okay, complete the cool down for lesson 3 in Canvas before you leave class. Okay, you're going to do this on your own. Use your notes in your workbook and then do your best. Don't just leave it blank or skip it, because this is an easy way to get a grade and give me feedback so that we can come back and talk about this before we move forward. All right, let's move into lesson number 4 and let's complete the bridge on page 37. So turn to page 37 in your workbook. You can pause the video anytime that you need to stop and work. And I would suggest that you try these on your own and then come back and then compare your answers with the video. All right, so in this bridge, we're given a function rule. We start with an input. Our input is going to be our X value. We put it into the expression and we work with that number or that rule to get an output or a y value. Y value is our output or your answer. So our rule is take our x, our input, divide by 4, and then add 2. Okay, so we're going to take these values. We're going to start with 0. So 0 divided by 4, if we substitute that in for x, is 0, plus 2 gives us 2. Okay, now let's go to the next value for x, 2. We're going to plug in 2 right here. Let me go down here. 2 over 4 plus 2. Now let's simplify that fraction. Divide 2 by 2 and get 1. Divide 4 by 2 and get 2. So 2 plus 1/2 is 2 1/2. Or you can write it as 2.5. Okay, now we're going to take 4 and we're going to substitute it in for x. So I'll move over here, 4 over 4, and then we're going to add 2. So what is 4 over 4? 4 over 4 is 1, and then 1 plus 2 is 3. So we should have 3 right here. All right, keep going. If you need to pause the video, pause it if you haven't done these yet. It helps to practice on your own before we uncover the answers. All right, again, we're going to put 6 over 4. We're going to simplify that fraction, and then we're going to add 2 to it. So we can divide both 6 and 4 by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So 3 over 2 plus 2, and 3 over 2 is 1.5, or 1 1/2. 1 1/2 plus 2 is 3.5, or 3 1/2. Question number 8. I'm sorry, the value for x is 8. We're going to substitute that in here. So 8 over 4 plus 2. 8 divided by 4 is 2. 2 plus 2 is 4. Okay, and then the last one, we're going to substitute in 10 for x. So 10 over 4. Let's go ahead and divide 10 by 2 and get 5, and 4 by 2 and get 2. So 5 over 2, 5 divided by 2 is 2.5. We're going to add 2 to that because that's what the rule said. 2.5 plus 2 gives us 4.5. All right, input is x. Your output or your answer is y. All right, now on page 37, complete the warm-up. Pause the video now, and then we'll come back and we'll look at this together. All right, the warm-up is just asking you, what do you notice? What do you wonder? So jot down those two things, what you notice and what you wonder. All right, we have a function rule, f of x equals 10 minus 2x, and another function rule in the second table, g of x equals 3 times x squared. So I want you to look at these carefully. Put in 1. Let's start up with the table on the left. Put in 1 for x. 2 times 1 is 2. 10 minus 2 is 8. So our output when we put in 1 for x and simplify, we get 8. Now go over to the second table and just take any one of these numbers. Let's skip the 0. Let's go to 1. Put in 1 for x, and then 1 squared, square the 1 is still 1. 1 times 3 is 3, so we get 3. But it's going to change when we get numbers bigger than 1 or smaller than 1. Okay, so we have some values here. What do you notice? What do you wonder? Some possible things you could notice is that the tables don't say input and output. or they don't say x and y. One function is called f and the other is called g. Did you see that? Okay, there's an expression rather than a number on the right side of the equation. F of x equals 10 minus 2x, and g of x equals 3x cubed, 3x squared. They have x cubed. I don't know where they got that. If we substitute the values in the left column for the x in the expression, we get values in the right column. So I demonstrated how we did that. So those are some samples of things you could have said, but there's many, many other things. So don't just, you can copy down my answers if you don't have your own, but your answers, when you're turning them in, they should never, look like the samples that I give you here. You should find things on your own. All right, now let's get ready for activity 1. We're going to have our input. Now, which variable is our input? That's going to be our x, and our output is going to be our y. And then in between that, we have a rule. This rule says to square the input and then multiply by 3. So we're going to take our input, we're going to square it, and then we're going to multiply by 3. Okay? The y value is going to be our output. It's also going to be the name of our function. Okay, so we can replace the function notation with y. So instead of saying f of x or g of x, we can simply say y. And we'll do this from time to time, but I just want you to know and recognize what function notation is saying. It's simply what we've named the function. Okay, we make a table, and the table is there to show the rule as a function given the x values. So let's go ahead and work through this. Again, we're going to square the x. So what is negative 2 squared? When you square a negative, you're going to get a positive. Negative 2 times negative 2 is positive 4. And then we're going to multiply by 3. So 4 times 3 would be 12. We're going to use that same rule, and now we're going to plug in 0 for x. So 0 squared is 0, and then 0 times 3 is 0. All right, let's move to 1. Okay, we're going to take our x value, we're going to square it. Okay, so 1 squared is 1. And then we're going to multiply by 3. So 1 times 3 is 3. All right, moving down to 3. We're going to take that x value, our input, we're going to square it. And then we're going to add, then we're going to multiply by 3. All right, so 3 squared is 9. 9 times 3 is 27. Then lastly, we have x. We're going to do the same thing. We're going to take x, we're going to square it, and then we're going to multiply by 3. Now we can write it this way, but we typically take that constant and we put it up in the front. And we write it as 3x squared. All right, turn to page 38. Here we're going to activity number 1, for functions. Okay, this is Unit 5, Lesson 4. So here are descriptions and equations. The descriptions are in words. The equations are on the right. We want to match each equation with a verbal description that represents the same function. So we have function f, function g, function h, and function k. Let's read A and let's try to find a match. To get the output, Output is our y. We're going to subtract 7 from the input. Our input is x. So we're going to subtract 7 from x and then divide this result by 3. Do you see a match on the right? X minus 7 divided by 3. Well, it looks like this one. Now I wrote mine straight across, but I'm going to write it the way that they wrote it. X minus 7. If we write that fraction bar, that's another way to write division. Okay, so A matches with function K. Now let's go to B. To get the output, remember output is y. We're going to subtract 7 from the input. So we're still starting with x and subtracting 7. But then we're going to take the result and we're going to multiply by 3. So put that in parentheses. Everything has to be multiplied by 3. And I see that straight across right here. Let's move down to C. To get the output, or to get your y, you're going to multiply the input. What is our input? Our input is our x. We're going to multiply by 3. So 3 times x. And then we're going to subtract 7. And here's the match in function f. And then finally D. All right, to get the output, again, that's why I'm going to label it until we understand and we get in the habit of just recognizing what input and output are. We're going to divide the input, which is x, by 3. Remember I told you that we can use the fraction bar for division? So I'll write it this way. Divide the input by 3, then subtract 7 from the result. See the answer here. So take those words, take them slowly, write it out mathematically, and you should find a match. How did we do? It looks like we got them right. Let's just double check. D, B, that is correct. All right, so let's move on to question number 2. For one of the functions, when the input is 6, the output is 3. Which is that function, f, g, h, or k? And explain how you know. So take some time. Let our input be 6. So we're going to take this, our input is x, and we're going to substitute that in for x to each of these functions, and then simplify. And then we're looking for when the output is -3. All right, you might want to pause right now, work through these, and see if you can find a function, either function f, g, h, or k, where the output is 3. All right, it's going to be function g, because if we put in 6 and then we subtract 7, 6 minus 7 is -1. -1 times 3 is -3. All right, so substitute -3 into each expression and check. And this is where we found our match. Function g is our match. Let's go to question 3. Which function value, f of x, g of x, h of x, or k of x, is the greatest when the output is 0? I'm sorry, when the input is 0. So we're going to substitute 0 for x, and we're going to simplify. So let's go ahead, and I'm putting the 0 above the x. 3 times 0 is 0, and then 0 minus 7 is -7. For g of x, we need to work what is inside of the parentheses first. We've got to perform 0 minus 7. 0 minus 7 is -7, and then multiply that by 3. 3 times negative 7 is negative 21. Okay, let's move down to function h. 0 divided by 3 is 0, and 0 minus 7 is negative 7. So that looks like that's the same as function f. Moving down to function k, 0 minus 7 is negative 7, and then negative 7 divided by 3 is negative 7 over 3. Now that we have the answers, let's compare. And we want the greatest. So negative 7 and negative 7 are equal. Okay, negative 21 is smaller than negative 7. And then negative 7 over 3. Let's go ahead and change that to a decimal. It's going to be a repeating decimal or a fraction. 3 goes into negative 7, negative 2 times, with one remainder, negative 2 1/3. Okay, so which one of these is the smallest? It's going to be negative 21. If you think about the number line, negative 21 is way over here. Then comes negative 7, and then negative 2 1/3 is right here. So the larger value is going to be negative 2 1/3. All right, so we were correct. Function k of x, has the greater value when x is, I didn't do it for 10 when the input is 10. I only did it when the input is 0. But it says here the greatest value when x is 10 is f of x. So we would do the same thing again, but instead of substituting in 0, we would substitute in 10 and then work through to find that f of x is going to give us the largest value. 30 minus 7 would be 21. All right, are you ready for more? My says that f of x is always greater than g of x for each value of x. Is that true? Yes, f of x is 3x minus 7. If you rewrite g of x as 3x minus 21, distribute the 3 into both terms, 3x minus 21, you will see that it will always be less than f of x. Let's move to activity 2 on page 39. And we're talking about area and perimeter. Do you remember how to find area and perimeter? Okay, if we have a rectangle, area is going to be length times width, and perimeter is going to be the length plus the length. We'll have 2 lengths plus, we have a width on the bottom and a width on the top, 2w. So the area is L times W. Now that's a rectangle. It's talking about a square. Let me start over here. So square, we have the same length on all 4 sides. So that's going to be S times S, or S squared. That's the area. The perimeter, we have 4 sides. They're all of length S, so it's going to be 4 times S. All right, we want to complete the table with the area for each given side. So we're going to take the side length, multiply it to itself. What is 1 times 1? 1 times 1 is 1. All right, continue with side length of 2. 2 times 2 is 4. Now if the side length is 4, the area is going to be 4 times 4, or 16. Continue with the side length of 6. The area is going to be 6 times 6, or 36. And if the side length is S, like I've labeled it here, the area is going to be S times S, or S squared. All right, now we have the areas filled in on our table. We want to write a rule for function A that gives the area of a square. Okay, we already have it here on our table. Okay, the area, okay, the function A of x is equal to s squared. So what does the function A of 2 represent in this situation? So A of 2 is the area of a square with a side length of 2. All right, moving on to C. On the coordinate plane, sketch a graph of this function. Okay, so we have the area, we have side lengths of 1, 2, 4, and 6. We have the area calculated on the right. Let me see if I have this written down in our book. This is on page 39. So turn to page 39. Fill this in, 1, 2, 4, 6, and S. I meant to have those covered up, but go ahead and fill these in. We've done this previously. 1 times 1 is 1, 2 times 2 is 4, 4 times 4 is 16, 6 times 6 is 36, and S times S is S squared. All right, now we're going to sketch the graph. Take a minute to sketch it and then come back and compare. All right, it should look something like this. 1, 1. So go 1, 1, go up a little bit. This is increasing by 10 units, so we're only going to go up a little bit, like right here. And then 2, 4. So 4 is a little bit less than half. And then 4, 16. I don't have a 3 here. I'm going to skip that. 4, 16 is going to be about right here. And then we go to 6. And then that goes up to 36. And then you're going to connect those dots. So it looks like it's curving up. So it should look something like this when you sketch it. All right, question number 2. We have a roll of paper that's 3 feet wide and it can be cut to any length. So here's a picture of the paper. If we cut a length of 2.5 feet, what is the perimeter of the paper? Take a minute to see if you can calculate the perimeter. Draw a picture if you need to. So we're going to cut this to a width of 2.5 feet. Remember, perimeter, we've got 2 of these. So we're going to multiply that by 2, the top and bottom. And then we've got a side of 3 and another side. So we've got 2 of those. So 2 times 2.5 is going to be 5. And then 3 times 2 is going to be 6. So 5 plus 6 should give us 11. 11 feet. Now complete the table with the perimeter for each given side length. Then write a rule for function P that gives the perimeter of the paper in feet when the side length of the feet is L. Okay, now we know that this is always going to be 3, but now we're cutting a side length of 1. So that would be 2 times 1 is 2 plus 3 times 2, 6. 6 plus 2 should give us 8. Let me write out this next one. Okay, so we have a side length of 2. We actually have 2 of those. And then this side length right here is not going to change. It's always going to be 3 plus another 3 over here. So that's going to be 2 plus 2, or 4, plus 6 should give us 10. All right, work on the rest of these yourself. Pause the video and then come back and compare. All right, for a side length of 6.3, we have 2 of those. Add those together to 3 plus 3, 6, and you'll get 18.6. All right, if we cut this bottom to 11, we're going to have to double that because we have a bottom and a top. So that's 22 plus 6 gives us 28. So what is the rule? Okay, we've worked through some of these. You should realize that we're multiplying the length that we're given by 2, and then we're adding on 6 to get the perimeter. So this is our rule for perimeter in feet. What does function P of 11 represent in this situation? And what is its value? So we're going to state in words what we're doing here. Okay, P of 11 is the perimeter of the paper in feet when the paper is cut at a length of 11 feet. Its value is 28. The perimeter is 28. All right, on page 40, part D, on the coordinate plane, sketch a graph of this function. Okay, so we're going to go back to what we did in the previous problem. Get those values back up here again. Okay, and then we're going to sketch it on the graph. So pause the video, graph the coordinate 1, 8, 2, 10, 6.3, 18.6, 11, 28, and then come back and compare to what I have here. All right, it should look something like this. Does your graph look like this? All right, turn to page 41, go through the summary and glossary. Again, take some time to go through this. I'm going to be checking your workbooks at the end of the week to see if you are taking notes and going through the vocabulary, the summary and glossary. So make sure that you're doing that. Asking questions before we start our next lesson. All right, complete the cool down for this lesson in Canvas. It should be there ready for you to complete before you start working through the practice problems. Complete the practice problems in your workbook and then transfer the answers into Canvas if there's a place for you to put your answers in.